Bob King, and I'll be doing the show tonight. I'm an amateur astronomer, live in Duluth, been here a long time. Love the northern lights, probably like you guys, and enjoy the stars very much, especially when there's not a lot of smoke on the sun. Tonight, it looks like it, according to the forecast, it's supposed to be clear, but we know there is some smoke haze here, so that will dim the stars somewhat, not too much. The moon rises late, so tonight you'll actually see a dark sky. Before we start, are there any questions? Any astronomical itching to know? Astronomical about anything? Well, feel free, obviously, during the presentation to ask anything you like. Tonight, we're going to lift off from planet Earth, and we're going to look way far and deep into the sky at other stars and other planets around those stars. So we'll start with, there we go. Thank you, Jessica. Jessica, who is the director of the planetarium, is back there, master controls, helping out. And here you have, wow, this is very lovely, Jessica, I would say. The sky is gorgeous. We'll look at the night sky too after the presentation. So we're going to talk about alien planets. Can you guys see okay? Great. And what's funny is that the title of this presentation, I think it was 5,380, I can't remember. But since the time that I wrote the title, they've discovered even more planets. So the actual number of planets is 5,389 planets that we know of outside of our solar system. Just I'm not getting any action.
Oh, that's my fault. Go ahead.
There we go. Oh. So I was going to start out with aliens. We've all seen lots of science fiction movies that feature aliens. And aliens, of course, come from planets. I mean, I don't have any proof. These are actual photos of real aliens. But some of them are our favorite aliens, or our children's friends, certainly, like E.T. When you see these creatures in various science fiction movies, whether they're friendly or scary, they come from somewhere. Oh, there he is, the greatest one of all, Yoda. And they hail from, not stars, because you cannot live on a star like the sun. It's a very hot, fiery surface. The sun, for instance, is 10,000 degrees. But planets are the places where, if we do encounter the first aliens or the first forms of life beyond our solar system, we're going to find them on planets because they're cooler than stars, and they make much better homes for life to develop and evolve. Lost it again.
Sorry, that was me.
So, alien planets, call it that if you like. What astronomers call them are exoplanets, planets that are beyond the sun, also called extrasolar planets. And that's what we're going to talk about tonight. So when you hear the word exo, it means beyond our solar system, planets that revolve around other stars. As I mentioned, there is quite a diversity of them. We have only been discovering new planets since the year 1992. How long ago was that? Like 30 years. So in 30 years' time, give or take, astronomers have discovered that number of planets, which is pretty incredible. And we've really only just begun. Imagine where we'll be in about 400 years, how many we'll discover. Based upon the discoveries we've made in the past few decades, astronomers estimate that there are far more planets in our galaxy than there are stars. Anybody know how many stars are in the Milky Way? Roughly? Just throw a number at me. Anybody? How many? Did you guys have a... Oh, no. They estimate about 200 billion. 200 billion stars. And I have seen estimates as high as 10 planets per star. maybe a little lower. So unbelievable. There are so many more planets out there, and that means with that many planets, there is a chance that one day we might encounter one that's like the Earth, where there are forms of life, habitable places, wonderful places, places where you go for a swim, places where you can see two stars in the sky, like you might see in a Star Wars movie. Luke stands out there on the planet Tatooine, if you remember, he sees the double star in the sky, the double sunset. Here are the names of some of those planets that you saw in the previous slide. I hope you remember that. It's a little broken up. But we have Dimidium, Arion, Orbitar, Hala. I like this one. Babarouche, Sazum, and it looks like Starbucks, but it's I hope there's no planet called Starbucks. These names come from people like us. The International Astronomical Union held a contest, a public contest across the world. And so these names are from people that submitted them from all different countries and different languages, including their own mythologies. Dimidium, for instance, means half. It's a Latin word. Here we have Dulcinea. If anybody's read Don Quixote or seen the play, that's from that book. And then Stavarags is the name of a famous cliff in Latvia. So it's really all over the map. These are official planet names. But before planets are named, extrasolar planets, they are given a real simple designation. They get the name of their star followed by the letter B. So if we discovered a planet around Alpha Centauri, we would call it Alpha Centauri B. And the next planet, if we discovered the second one, we would call it Alpha Centauri C, D, E, and so on. Eventually, those planets will be getting names, like these wonderful names that you see up there. It takes time. Now, the first planet was discovered in 1992, but the first one around a star like our sun. We're especially interested in planets around stars like our sun because our sun lives a long, 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 long time. And that allows for potentially life to develop around a planet orbiting a sun-like star. The sun's been here for nearly 5 billion years, and it's got about 5 billion to go. Here's Dimidium, formerly known as 51 Pegasi b, because it's in the constellation of Pegasus, the flying horse, 50 light years away, and Dimidium means half in Latin, and the reason they call it that is because it's half as massive as the planet Jupiter. So, a perfect name. One of the first named exoplanets is Dimidium, discovered in 1995. Now, that one was found by a telescope that's on the ground. But NASA decided that the best way to discover exoplanets was to dedicate a mission in space with a special telescope. And so they devised the Kepler Space Telescope. And between those years, you see up there, 2009 to 2018, that thing orbited the Earth, and it focused on one section of the sky, nonstop. It's like you or I, if we were to go out and stay up all night and never close our eyes for 9 years in a row. And it just stared at a patch of the Milky Way, a very familiar part of the sky, right up near the summer triangle. You see that circle? That was Kepler's patch to look at inside the Milky Way. There's lots and lots of stars. And so it was just staring blankly, night after night, day after day, 24 hours a day, of course, since they're in space. And what it was waiting for, after it looked at 500,000 stars, it was waiting for some of those stars to blink. In other words, for the star to get dimmer and then brighten again. We call it blink. It's a very easy concept to understand, and it's one of the main ways that we've discovered exoplanets, is when the planet around the star crosses in front of it, and it temporarily dims the star. The astronomers can measure that light, that dimming, and they can tell you how big that planet is. And if it repeats, because Kepler's just staring and staring, if it repeats and it blinks at the same time, every time, like once a year, once every days. Then we can tell you how big its orbit is, how long it takes to go around that star. So this is my own really cheap transit. It's called the transit method because your planet is transiting or moving in front of the star. I used a fake planet. Took the shade off my lamp. I know it's kind of low-tech graphics. Here's the high-tech graphic. Transit method. There goes your planet. Here's the light of the star before the planet crosses. Whoa! Watch it dip down as the planet, and then it goes back up to its normal brightness. These are really tiny little dips of light. So you need big instruments, large telescopes to see these changes. But with that data, you can determine many things about planets and discover many planets around stars. Yes.
If there's multiple exoplanets orbiting around the star, would they be able to tell that using the transit method?
Yes, great question. What if there are multiple planets? It's really a good question. Because I'm only showing you the simple single planet seen here. If there are multiple planets, each one of those planets is in their own orbit. So it would have its own period of time. And we would associate a particular dimming with just that orbital period. Does that make sense? So if there was one moving around every 3 days, one every 8 days, then we could start to separate those out because of the different length of the time they go around the star. Great question. Using this method, most of the planets, and certainly the very first planets that we found, were hot Jupiters. You guys all know about Jupiter, right? The big planet way out there past Mars. Very cold place in our solar system because Jupiter is far from the sun. These are hot Jupiters because they're like Jupiter, almost as massive, sometimes more massive, but they're close to their stars. And that makes them easy to find. Why do you think they're easier to find? If you have a giant planet close to a star, when it crosses, it makes a really obvious dip, doesn't it? But being close, it must be very hot. So that's why we call them hot Jupiters. Still waiting for a dance club to be called that. Could happen. That's not the only type of exoplanet that we found. Even though a great many of them are kind of Jupiter-sized, very massive objects, we have developed finer and finer techniques, larger telescopes, so that we've gotten down to the level of finding Earth-sized planets now. And Earth-sized planets are fascinating because the potential, again, is there. Maybe there would be life on some of these Earth-sized planets. This is one that Kepler found. Doesn't have a name yet. It's just, what do I have here? 186F. So that's the name of the star. And F means it's the A, B, C, D, E. That's the fifth planet orbiting that star. And here it is, just a little bit bigger than the Earth. Of course, that's just an illustration. I wish we had a photo. There are photos. You can go online and look up exoplanets and you'll see pictures of them. But they are so tiny. Yeah, I mean, we can't even see the star. We can't see the shape of the star. Nor can we see the shape of the planet. They just look like bright points of light. So you see pictures of exoplanets. We don't have anything like this. This would take a telescope as big as from here to the moon to actually see the disk of an exoplanet. Just a point of light. So here's this beautiful planet. We don't know if there's life on it, but we do know it's about the size of the Earth. It orbits close to the star. It's probably too hot. Wait, is that in the... Oh, sorry. That star, Kepler 186, not all of those planets are in this special place, but that one happens to be. It's in what we call the Goldilocks zone. You guys ever heard of the Goldilocks zone for planets? Some of you may have heard it. Of course, it refers back to the Goldilocks and the bears, the story, when she went and got that porridge. There was the too cold, then this is too hot, and then this porridge is just right. So applied to planets, that means a planet, when it's in the Goldilocks zone, a planet is located in a place close enough to its star, but not too close, for liquid water to exist on its surface. There would be ponds and oceans and lakes and liquid water is, again, something we know. we gotta have, right, as living beings, and so many living beings do require water, so if liquid water is there, there's possibly what we need, ingredients for life. So we're looking for Earth-like planets in the Goldilocks zone. Somebody should write a story about that, just a kid's book. So this is Kepler 186f. Here's its Goldilocks zone, its star. Here's the other little planets. Notice they're too close to their sun, so it's too hot there. But this one's in just the right place. And look where we happen to be. Earth's also in the Goldilocks zone. So we know it's a great place to live. I think so, right? It's still a good planet, isn't it? Yes, it's the best place out there. Kepler was retired in 2018. Is done. And NASA built another satellite that is operating right now called TESS. And you can read the name there. It's called TESS. And TESS is out there discovering even more exoplanets. As of November of last year, it discovered 273 new planets. And it's got a wider field of view. This, instead of concentrating in one spot, the Milky Way, like you saw, this has a much broader view. And it's looking for planets around close, bright stars, so that when it discovers them, we can use telescopes on the ground to really hone in and examine those planets and maybe get to see what their atmospheres are. Are you guys familiar with the Doppler effect? Maybe you've heard of the Doppler effect. When an ambulance, we've all been in our car or standing in our lawn or whatever, when an ambulance is approaching you, the sound waves are compressed and the pitch goes up. And then when the ambulance passes you, the sound waves are stretched out, like you see on the left, there's more space between them. And so to our ears, we hear a lower pitch. And I've got it, I think I can hear it. Oh, that's enough. But you heard the Doppler, you guys heard the Doppler effect right there. Approach and then leaving. So, the same thing, this is what's so cool about this. That's because sound waves are being squeezed as it approaches and getting stretched apart as it leaves. The same thing happens with light. Okay, that's about enough of that. The same thing happens with light. You're wondering, why are you telling us about this Doppler effect? Just hang on for 1 minute, because I'm going to show you the second way that we have found exoplanets. There's a bunch of ways. The main one is the transit, and then the other one is using the Doppler effect. So when a light beam is moving away from you, let's say the sun decided to take off across the other side of the solar system, its light would be shifted to the red. That's the same thing as the pitch of the ambulance dropping lower. If the star, or whatever it is, was approaching you fast, then the waves of light get squeezed, and the object goes bluer. So you can use this to your advantage if you are going down 21st Avenue East, and you're traveling about half the speed of light. You can turn that red light green because your Doppler shifting into the blue. It has to go through green first. No, you would not want to do that, because that would be a terrible thing. But the same thing applies. So how does that work with exoplanets? Well, planets have pull, right? The Earth's got gravity. What does the Earth's gravity do in our neighborhood as far as other objects? Anybody? Holds the moon, kind of. The moon goes around it, kind of a big planet. Planets around other stars can pull those stars towards them and then away towards us or away from us. You see here we have a little planet. Here's its sun. And as the planet goes around the sun, it's tugging it one way, moving it farther from us so that its light becomes redder. And then it's pulling it back the other way towards us, so its light becomes bluer. You can take a telescope with a very sensitive spectroscope on it, and you can measure that shift, and it will tell you how massive that planet is that's doing the tugging. So that's really cool. So you can use just blocking the object, like we saw with the transit, or you can use the tug that causes the star to wobble to determine We use space telescopes for the transit ones, and ground telescopes do a good job on the ones that fly. So between the two, we've discovered over 5,000 planets. This is the biggest telescope here in the United States, certainly. 394-inch, two of them side by side. Always good to have a spare. And they're wide. So if we look at what we've discovered, we have discovered planets similar to what we have in our solar system. You see there on the left, we've got Jupiter-sized planets, for instance. That's familiar, except that some of them are much closer than we ever imagined a giant planet could get to their star. And those are the hot Jupiters. Then we have Neptune-like planets, including mini Neptunes, which are a little different from our Neptune. And Earth-type terrestrial planets with atmospheres, that have water vapor in them, carbon dioxide, maybe even oxygen. And then there's my favorite, super-Earths. Terrestrial planets that are more massive than our current Earth, but lighter than Neptune. So we've discovered new types of planets, including some, and then also some familiar ones. The closest exoplanet is not far away. If you've ever been to the southern hemisphere, or even in the Caribbean, maybe you've seen the star Alpha Centauri. Alpha Centauri also has another star going around it called Proxima. And Proxima is the closest star right now to the sun, a little over 4 light years. Isn't it great that the closest star to our star has an exoplanet, and it's about the same size as the Earth? Who knows? Maybe there are life forms there. Maybe that will be the first place one day in the future that we send a spacecraft to explore. We could land there. We could discover something in a whole different solar system. Here's just a scene, an imagined scene of Proxima. It's Proxima B. It doesn't have a name yet, so it's Proxima B. And there's its star. Its star is different from ours. It's called a red dwarf. It's a much smaller, fainter star. So to get the warmth it needs for life, the planet has to be close to that star, closer than we would be to the sun. One of the coolest systems of all, and this is an entire solar system of Earth-like planets that are all inside the habitable zone, or the Goldilocks zone, is around a star, a little red dwarf. There you see it compared to the sun. Our sun is small compared to some really big stars, but it's big compared to these little red dwarfs. Around this star, check out how many planets we've got. And those are the sizes of the planets compared to our own. So here's Mercury, Venus, Earth, Mars, and there's the star, B, C, D, E, F, G, A. It's like going to kindergarten and learning the alphabet. You learn these planet names. And look at them. They're 40 light years away, not terribly far, in the constellation of Aquarius, the water carrier. And they are a full-scale solar system of a bunch of Earth-sized planets, which is amazing. We don't have a solar system like this, but there is one out there that does. TRAPPIST, I wrote the name down, and I probably can't see it here, but when the light comes on, I'll let you know. It's an acronym, of course. Now, one difference between our solar system and the TRAPPIST-1 system is our planets are spaced out from close to far, but all those planets you saw are located there in relation to our solar system. So all 7 planets are like really close to the sun. Their star, their sun. They orbit anywhere from a half a day to 19 days. So if you live, for instance, on TRAPPIST-F, which is on the outer fringe of this, the one that takes 19 days to go around the star, looking back towards the sun, you would see just all these planets in the sky, because you're all so close and buddied up with one another. I know these are real scenes, but I show them to you anyway because I want you to imagine that these are real places that you can, that are out there, that one day maybe we visit, or maybe we'll have better pictures of too. One of the reasons we look closely at these exoplanets is And one of the reasons the Webb Space Telescope, which was launched, you might remember earlier this year, and it's just done spectacularly, that Webb Space Telescope is taking pictures of closer exoplanets, trying to determine what's in their atmosphere. Picture a planet crossing in front of a star, like you saw in the beginning. I had the little planet in front of the light. When it crosses in front of the star, some of that star's light goes through the planet's atmosphere. And that atmosphere leaves a fingerprint that we can read back home. We can say what's in there. And when Webb took a look at this star, which is called Boca Prinz, the constellation pardon me, I misspoke. This planet, Boca Prinz in Virgo. Boca Prinz, by the way, is the name of a beach in Aruba. Everybody's been out of the Caribbean island. Who came up with these names? The International Astronaut Community will have another public naming contest, and I would urge you to get involved and see if they'll accept your submission. So think of some cool names. Here's the Earth for comparison. Boca Prinz is a pretty big planet. And when Webb looked at it, it found water, sulfur dioxide, carbon dioxide, a few other things in the atmosphere. So we can really start to see. Oh, you guys, we're going to have the star show in just a minute to stay, in about 2 minutes. Oh, that's okay. So that's kind of what we want to find. What other things would tip us off that there might be life on a planet if we found out other gases in its atmosphere? Anybody have a guess? What's a good life gas? I hear it. Oxygen. Yeah. If we found oxygen in an atmosphere, if we found maybe methane, industrial products, who knows? That would be a really great target to just focus everything on to study. So all of this stuff eventually is going to come together. The hope is that we can begin to focus and find planets that may have life, and maybe even attempt to contact them. Slides.
Try now.
There we go. All right. So, I'm not going to leave you tonight without pointing out a place where you can at least imagine an exoplanet. Have you guys noticed Venus in the evening sky? That really bright thing in the western sky, that bright star that shows up during evening twilight. That brilliant object is the planet Venus. And tonight, if it's clear, you can look west at around, starting after about like 10 o'clock, 10:30, because it just gets dark so late. I hate to see those times, but it gets dark at that time. You're out at 10:30, 10:15, you see Venus, and if you look to the right of Venus, a little below, you're going to see 2 stars in the constellation Gemini. Pollux. Pollux is a little brighter, and Castor. Guess what? Castor has an exoplanet. So you can look at Castor and go, hey, there's a planet around that star, even if you can't see it. And here's a little bit about it. It has a name. It's called Thestius. Thestius. And Pollux is about 34 light years from the Earth, and it's twice as massive as Jupiter. So it's a big planet, isn't it? It takes almost 2 years to circle Pollux, and it's out there. Who knows what's happening on Thestius tonight? Maybe there's someone doing a planetarium show with a very different view of the tight sky that we have here. Maybe they've discovered Earth. For them, our planet is the exoplanet. So with that, my presentation portion is finished. Before we go to the stars, so I can show you the nice constellations you'll see tonight and on the next clear nights. Do you guys have any questions about anything that came up in the presentation?
That was a good old report.
Yeah.
We know about 20 years ago,
Just Victoria provides just
Yeah.
sorry.
no, it was about 20 years ago, there was other planets that we thought that might have been orbiting around our sun, and maybe a ninth star a long time ago. Do you know anything about more about what happened to that?
You like planet, what do they call it? Planet 9?
It was like the 10th planet after
Or the 10th planet, yeah, before Pluto
It
is.
was like super far out, but it was like over maybe ours and maybe a dead star.
Yeah, the Dead Star idea was dead.
Okay.
But the planet might still be there because there are some asteroids way out there in our solar system. Their orbits seem to be affected by a massive object we cannot see somewhere beyond here. And so there is the potential that there is a ninth, call it 10th planet if you're a Pluto fan. There is potential that there is a 10th planet actually. It's just the farther away you get, the fainter everything gets. So it just becomes harder to see. Don't know exactly where to go, but I know people are still looking. And I think there are other things out there in that darkness that can get to the stars. I think that's what you're referring to by the planet. We don't have evidence for it, just circumstantial.
Yeah, it's hard to, because you can't really, it doesn't go in front of our own sun, it goes all around the other way, so it's really hard to actually track it as we see it by.
Exactly. Yeah, you've got the concept, totally, right. So we can't see it, but there are other ways. One thing that planets do is they absorb light and energy from the sun. And so they warm up compared to the temperature of space. And so if we ever were to discover a planet out there, we would probably use an infrared telescope, which picks up heat radiation, rather than a normal scope. There's more likely more heat coming from it than reflected light. So I hope we're all around when that happens. I'd love for there to be another planet, number 10 or 9, whichever. Any other questions you guys might have? All right, look at this. Huh? We're going through the light tunnel. Better buckle your seatbelts. Okay, we're going to take a look. Sometimes we use this projector here from the 1960s. This is a lovely projector, but Jessica has something called Digistar. So when you put digit in front of anything, it just makes it one level cooler. So we're going to do that this evening and look at what you can see in the dark sky. Then you guys catch the moonrise the other night? It was a little foggy. There was a full moonrise though. It was kind of hard to. I went to Skyline Parkway. It took about 15 minutes to get above the haze. So I
You
think
said
we're good.
to 10:30?
10:30. We're going to set the sky to 10:30.
Oops. There we go.
Bright Saturday. And we are facing to the north. And I bet you know how you can figure out that you're facing north. Oh, I suppose we turn off the these.
The what?
No, the lights on the paintings.
Oh, yeah, I can do that.
Dang, great. So if you look to the north, this is a good example of kind of a smoky sky. You'll see the Big Dipper way up high. Maybe you've already noticed that when you've gone out at night. You have to crane your neck way up there, and that is the Dipper. It's high right now, high in the northwestern sky. This is our north point right down here. Right? Now, if we take the bowl of the Big Dipper, go down here to the end of the bowl, and draw a line through it, you'll come to the North Star. That will always point you, the bowl will always point you to the North Star, that pivot star in the sky. All the stars appear to turn in circles around the North Star because the Earth's north polar axis, remember the old axis diagrams? The axis is pointed at the North Star. So as we spin, it stays in the same place, and all these guys do this. Circle around. If you have a good view to the north, very low, you're going to see kind of faintly down here the outline of Cassiopeia. You see the W? This is the time of the year when it actually looks like a W, but it's hiding out. Normally when we see it, it's up on the side, looks like a zigzag or an M, but now it's pure W-ness down there low in the northern sky. Is this the faintest stars that are possible?
No, I can go later into the night.
Oh, great. Let's take it a little. We're going to go a little bit later so you guys can see more stars. So we have the Dipper on one side. We have the North Star, which is Polaris. Down here, a little bit of help. You can see the outline of Cassiopeia. Now it's closer to more 11 o'clock-ish. Okay, we're getting towards the end of twilight, so we can see more stars. It's that twilight that makes stars difficult to see. We need true darkness. And that will help us find not just the North Star, but the Little Dipper. You see the handle of the Dipper here? There's the back of the bowl, and there's the front of the Dipper bowl. So you can see Ursa Minor, for the Little Dipper. And here's Ursa Major, or the Great Bear, the Big Dipper. And we've added in lines to connect other faint stars near the Dipper that outline what I'm sure you're seeing right now as a bear, right? Definitely, pretty much. How about a raccoon? You know what? I just saw a skunk in my yard digging for beetle bark. And there it is. That's the skunk. Totally skunkish right there. Look at the length of that tail. Tell me that's not a skunk. So we have Ursa Major and Ursa Minor, which is the little bear. And then down below, Cassiopeia, the W, is actually a queen. She represents the mythological queen. And those are our bright, easy constellations in the northern sky. Those three groups. Oh wait, I'm sorry, there's one more. Would you guys like a fourth one? This is such a great constellation. It's called Draco the Dragon. Named after Draco Malfoy in the Harry Potter series. We have the Big Dipper, remember? So you can use, this is how it is. You can use the Big Dipper to find like 10 different constellations. You know this spot in the sky, you've got yourself a marker. So we have the Dipper. Instead of going all the way to the North Star, let's stop at the very first star we see outside there of the ball. That is the tip of the dragon's tail. Now you can already see we are really looking at a dragon here, can't you? And there's the head of the dragon. And I bet we have a mythological figure that's just some scary, no, probably. There it is. Long before the TV series with its many dragons. What was the name of that? Who can help
Are
me?
you talking Game of Thrones?
Yeah, long before Game of Thrones. The ancients put this wonderful dragon, Draco, in the sky. So we're going to turn now to face the western sky. Because in the west is where you'll find Venus. And we have made this a little bit late, right? Because we made it at 11 o'clock, but maybe we could back it up to 10:30 again. Is that
Yeah,
possible?
I can do that.
She can do anything. I believe if you come up after the show, she'll be able to tell you your fortune in the stars. So we have down here, let's see if I can find it. Oh, yes, here we go. Down here, these are Castor and Pollux. So you remember that with the exoplanet? This one here is Pollux. And then this bright star here is Venus. So we look to the lower right of Venus to see Castor and Pollux. Pollux, the brighter one, is the longer planet. While you're facing west, I want to point out one other constellation. You might not see the whole thing. Oh, there we go. Oh, that's Venus. Yes, that's much better. It's flipped off there. So Castor and Pollux, Venus, and once it gets a little darker, you will see the planet Mars to the upper left of Venus. So we have Venus and Mars as our evening planets. Venus is much brighter than Mars. Jessica, I wonder if you could outline Leo for us.
Yep. Sorry, I
Above
gotta
them,
find it.
you can continue to the left and above with the darker sky, and you will see a backwards question mark right here. At the bottom is a bright star called Regulus, and this means little king. And this is a lion's, actually a lion's head, and you connect the lion's head to these three stars, which form its tail, and that forms Leo the lion. So that's really cool. It's a nice constellation. There's Leo right there. Can you see?
Sorry, it took me a minute to find them. There's a lot of constellations on this panel.
So it's nice to be able to have these figures, you know, to be able to help us imagine what's up in the sky. And now we'll turn to if we could turn west, or pardon me, not west, but south. And we'll just linger a little bit in the south. Wow, that's really nice. And do you mind making it 11 o'clock again?
Yep.
So we get that beautiful dark sky. Thanks. When you face to the south, so you're outside, right? And you're just turning your body. First you face to the west in the sunset direction, then you pivot it so that you're facing south. Just a quarter turn, right, on a circle. when you face south and you look up really high, you'll see a very bright orange colored star named Arcturus. Very close, very bright, you can't miss it. It's like, what is that bright star high up in the southern sky? And it forms the bottom of the ice cream cone-shaped constellation called Boötes, which is a herdsman. So here's your ice cream cone. Got that? It's a sugar cone, so it cuts off right about there. There's the cone line. And then this is where the ice cream. So if you find Arcturus and you extend lines upward that way, either side, you might be able to find Boötes. B-O-O-T-E-S, the ice cream cone-shaped constellation. Another, and one of my very favorite constellations in the southern sky this time of year, comes up after 11 o'clock or so in the evening. Way down here in the southeast is a bright star, another bright star, kind of orange colored, the same as Arcturus. This is Antares, and it's the brightest star in the Scorpion. There's the head of the Scorpion, there's Antares, called the heart of the Scorpion, and the tail kind of dips below the horizon and comes back up. Now that is a groove. Yes, indeed, proof it looks like a scorpion. Total proof. So we have Boötes way up high with its bright orange star. And then we have Scorpius, one of the zodiac constellations, down low in the southeast. And our final act tonight will be to face east. And when we face to the east, oh man, look at this. What is this? You guys know what that is, right? The big arc, the Milky Way. On a dark night, wow, what a spectacle that is. That's made up of all those 250 billion stars we talked about, but they're so far away, most of them, that they blend together just to make it look like haze. When we face east, around 11:30, wow, the summer triangle comes up. You see that? The brightest one on top is Vega, down below is Deneb, down here is Altair. Altair is in a constellation called Aquila, the eagle. Vega in Lyra, the lyre, it's like a little harp. And then Deneb is in the northern cross, or Cygnus. And you can look at it as a summer triangle, or given that it's summer, you have my permission to view it as a slice of pizza as well. So whatever works best. And that's our tour of some of the brighter objects of the nighttime sky. And we'll bring the lights up here. Thanks, Jessica, for your help. And I really hope the smoke stays away so you guys can enjoy a nice night with the moon. You'll be able to see the Milky Way now. Planets are all good. There are 2 morning planets too, but we'll wait till they move into the evening sky. I'm guessing you guys, how many people here get up at 4?
Does it count if I'm still up by
If
4?
you're still up, it counts. That's good. Do you have a job? Oh, see, yeah. So we could talk about just with you. We do a special session. Any questions, guys, before I let you go? I have a maybe special treat after this. I don't know. If it's clear out, I brought a telescope for observing the sun. So I will set that up. It just takes a minute. So head outside. And I thank you very much for your time. Appreciate what you came today. Thank you.
All right. Gonna say a quick thank you to everyone who joined us online. And yeah, thanks for everything. Bye, guys.